question firstly asks us to start by considering if this is the original function, that we can show that the derivative becomes this that's written over here. So I'm going to start by looking at term by term using the power rule. So this becomes 3x squared minus 6x. Then I'm going to take out a factor of 3x from both terms. Take 3x out of this, it's going to leave me with just an x. I take 3x out of this, I'm going to get with minus 2, and then you can see that that is exactly what I needed to show from here. The next thing says show that there is a maximum turning point here and a minimum here. So to do that, the first thing that I need to do is find the turning points, and then I can show that they are indeed a maximum and a minimum. So I'm going to set the derivative equal to 0, and then I'm going to solve. So that means I'm going to have 3x times x minus 2 equals 0. That means either this part or this part equals 0, because that's the only way that two things multiplied together can equal 0. So I say that either x equals 0 or x equals 2. We can see here that these are the two coordinates that we've been given to show 0 and 2. So what we're going to do now is we're going to set up a little table for x and the derivative, because we want to see if the derivatives are positive, if they're stationary, which means flat, or if they're negative. I need to put in the points 0 and 2. And then I also want to check around those points. So I want to check a point in the middle here. I want to check a point off to the right. And I want to check a point off to the left. Now, this one and this one, we might be able to put in straight away if we're familiar with the shapes of curves and the behaviour of functions. This is a positive cubic. So we know that for positive cubics I'm going to start and end in those directions, which means on the extreme end here it's positive, and on the extreme end here it's also positive. So that could help us without having to then do more calculations. So I'm just going to leave that here as positive and positive. And I'm not going to actually work that one out because I'm familiar with what this function looks like. Of course, if you're not sure what the extreme of behaviour is doing, like what this is doing, you'd have to actually plug in minus 1 into the gradient function and then see if that became positive or negative. I know that at 0 and 2 I've got flat spots. So all that's left now is to see if this point here in the middle is positive or negative. So I'm looking at the function 3x times x minus 2. I'm looking at that evaluated at point 1, so this will become 3 times 1 minus 2, which is minus 1. It's minus 3, which is very definitely negative, so it does this. So you can see here that I'm going up, flat spot down, makes this one a maximum turning point. This one's coming down, flat spot up, makes this one a minimum turning point, and that's what was asked right at the very beginning. The next thing says then to sketch that using all this information that we've now got. So let's see how we can go putting this all together. First thing I'm going to do is I'm going to look at my original function y, and I'm going to factorise this to look like this. This gives me roots at 0 and at 3. So when I'm sketching this function, I'm going to have a root here at 0 and a root here at 3. You can also see that at the point when x is 0, there is no y-intercept, or the y-intercept is 0, 0. That makes sense because it is also a turning point, 0, 0. In fact, it's a maximum. So now I'm going to be doing this at this point here. Here at the point delta is 2. We've also got another flat spot. We know that it's 2 minus 4. We also know that it's a minimum. So we want it to do that. And then it basically becomes a dot to dot. We know it goes through the roots. We know that the end behaviours do that. And this here is the point 2 minus 4. And there's our sketch.